a SOLIDWORKS part and print it on the Stratasys F370 3D printer. The F370 3D printer is a fused deposition modeling, or FDM, printer that uses a solid plastic filament material. Before printing anything to a 3D printer, we need to get the SOLIDWORKS file into a format that's compatible with the slicer software of that 3D printer. Typically, 3D printers use the STL file format in order to process and prepare files for 3D printing. To get a file into STL format from SOLIDWORKS, the first thing is to click on File and Save As. From there, you can click on the Save Type and select STL. You want to name your file appropriately, and here at the CCIC we use the format last name followed by project name. So make sure to save your file with that file name, and all you need to do is click on Save. The other thing that is important is make sure you're saving to a folder where you'll find it again, and in my case here I'm saving it onto my desktop. After clicking Save, you now have your STL file. It will come up with a message saying that it's converting it into triangles, and that just means that it has created a format that the STL printer can then read and process. Once you've created the STL file, you can now move into the 3D printer software to get it ready for 3D printing. This is often referred to as slicer software, meaning that it takes the file and cuts it into layers, which then can be printed one layer at a time on the 3D printer. In this case, we're using GrabCAD Print, which is the software used by the F370 printer. You can see here that we have a blank tray ready to go, and what's important is to select the template for the machine that you'll be using. In our case, we need to look for the template for the F370 printer, so you'll need to scroll down the list until you find the Stratasys F370. One thing you may want to consider doing is clicking on the star, which adds it to your favorites list, and we'll put that at the top of your menu so that every time you start into the software, you'll conveniently have access to that template. Once the template is selected, you are ready to move on to the next step. You can go over to the Add Models tab, click on that, and it'll open up the directory where you can then select your file. In our case, we saved our file onto the desktop, so we want to look for our file on the desktop and make sure to select the one that's in the format of STL. Once we select that file, we can click Open, and GrabCAD Print will automatically add it to the tray. More files could be added to the tray at this point, but for now we're just going to work with this one file. You'll notice that our file was oriented in a certain way based on how the GrabCAD Print software chose to bring it in. We can change the file's orientation, and we can change a number of other settings. Up at the top right, you'll see there's a menu with a blue box that's selected, and that is our Model View menu, and we'll spend most of our time in that menu. When you have that selected, you'll notice there's another menu below it that has many other icons that we can select from. So the first one we'll select from is the units. We want to be sure to be using the units that are associated with our part. In this case, this part was built in millimeters, so if I click on the Units tab, it will show me that it was done in millimeters. If I change it to inches, what it will do is scale it to that same number of inches, and you'll notice my file becomes enormous. I have to zoom way out in order to even see it, and it's obviously way too big to print in the 3D printer. So we want to make sure to use the units that our file was created in. Now I have to zoom back in so I can see the file, and you can see it's restored back to its original size. The next menu is Tray Settings. And within Tray Settings, we can tell it what kind of material we're going to be using with our printer. In this case, we're going to be using ABS plastic, so we just need to select the F123 ABS option. The other options are defaults, and typically we do not need to change any of the defaults here, so we'll just leave them alone. The next option is the model settings. The primary thing that we're going to control here is the infill of the model, or in other words, how solid the model will be when we get done creating this model. An infill on the far right in the black box is solid. That means that the thing will be solid plastic when it's finished. Obviously, the part will be very, very strong, but it will also weigh more, and it will use a lot of plastic in the process of printing. So rarely do I ever print a part solid. You rarely need that kind of strength. In fact, I usually print using the sparse infill pattern, which you can see on the far left. That has the most hollow setting, and it does have a slider bar that's adjustable, so you can change the default settings to some other settings. But I typically leave mine at the default setting, and you can always say restore to go back to that default setting. In between, you'll see there's other infill options that can be selected, and so you can always have more infill if your part needs to be stronger. But generally speaking, for the purposes of a prototype, you may not need as strong a part. Perhaps when making a drone or some other part for something that's going to have to be fairly sturdy, you may want to go with one of the more dense infill patterns to give it additional strength. But again, rarely do you really need to select the solid infill pattern. Support material is the material used to hold up the part while it's being printed, or in effect, to act as a mold. One of the beauties of the F370 printer is when it needs to fill in a space, like the one shown here on this part, it will do it using a soluble support. Soluble support means that the support can be dissolved in a mild acid bath after the part is printed. So if we were to print the part in this position, that little upside down U-shaped opening would be filled in with support material, which would have to be removed from the part once it was done. Typically, the support settings used in GrabCAD Print are perfect if you just use the Smart Support option. It's a very intelligent support option, and the software will take care of most of the default settings that you need. You'll notice there are other options on the menu, but just select Support, Smart Support, and you should be fine. The next option on the menu has to do with arranging the tray. This would be primarily in the case of having multiple parts on the tray. You'll notice, by the way, I can change my view of the tray by right-clicking and moving my mouse, which will reorient the tray. I can also zoom in and zoom out using my mouse. If I click Arrange the Tray, if I had multiple parts, GrabCAD Print will automatically move those parts around into the most efficient pattern. You'll also notice there's this funny-looking bow tie shaped piece of plastic that's showing that it's going to print behind my part. That is what's called a wipe tower, and the wipe tower can be used to keep the head clean during the printing process. So the head will print a little bit of your part and then go over to the wipe tower and wipe off any excess plastic and then come back and continue printing your part. You can auto-arrange the tray and have it set up the tray the way you want. Similarly, the next option down has to do with orienting the part for printing. This is a very important setting because it will determine how much support material your part will require. You'll notice here that I was able to select Auto Orient, and GrabCAD Print oriented my part to be standing vertically, pretty much like it was from the outset. But you'll notice the box turned red when it placed it. By just dragging my part back into the build area, I can make sure that my part is acceptable to GrabCAD Print. If I do another auto arrange of my parts, you'll notice that it put the part on top of the wipe tower. So one thing you can always do too is move that wipe tower over onto that little tab in the back of the print surface, and you can place it in that location to get it out of the way. One thing though that's important is to keep the wipe tower and the part close together so that the head does not have to travel long distances between printing the part and wiping the head. And so I usually try to keep the part and the wipe tower located fairly close together. You will notice if I go to auto arrange, it will pull the wipe tower back off of that little tab. So I just manually move the wipe tower back to that little tab and then manually move my part back close to the wipe tower, again, to minimize distances between the two and to speed the printing process. One other option, if you think you want to print your part in a different orientation, is to select that you want to orient the part. And what you can do is, in this option, move and select a face on the part, and then it allows you to select whether you want that face to be the top, the bottom, the left, the right, and it will automatically reorient the part accordingly. So in this case, I selected the face on the side of the part and said make that the bottom, and GrabCAD Print automatically rotated the part to be flat on the tray. If I click Auto Arrange, you'll notice it stands right back up again. So the GrabCAD Print software believes that that's the best configuration for printing. And in a minute, we may see why. You will notice, though, that when the part is laying flat, the wipe tower is much shorter, and so it does not take as much material to build up the part. However, this orientation does require a lot more support material, which is a negative. Here I'm again using the right mouse button on my mouse to rotate the part around and to see the tray. You'll also notice some helpful tools across the top whenever you're trying to look at what you're doing. There is a top view, a right view, a bottom view, isometric view. There's all kinds of views that you can select from. So in this case, that's the front view, and now I can select the isometric view, which is the view I often work with. You'll also notice there's some quick zoom tools out on the right-hand side. If I say zoom to all the parts that are on the tray, it will zoom in to whatever region it needs in order to see all the parts. I can zoom out and see the entire tray, or I can select a part and then say zoom into that part. So in this case, since I only have one part on the tray, it's not very exciting, but that is the way you can control your different views very quickly and easily. Once I have the part created, I can also scale the part. You'll notice that I have a scaling tool over on the right-hand side selected, and I can scale it. Now, the downside of scaling a part is typically when we create parts in SOLIDWORKS, we do so to a specific size. By scaling a part down using the scaling option at the bottom of the menu, we end up making a part smaller than what we designed it to be. That's great for prototyping, but if you were trying to create an assembly where all your parts had to fit together, scaling would result in your part being the wrong size for that assembly. So it's best to make sure to print things the original size unless there's some really good reason for printing a smaller version. Down at the bottom left, once you've got everything set up, you can click on the Estimate button. You'll notice that it pops up a menu and shows you how much time it's going to take to print your part, and also how much model material and support material it's going to use. In this case, make a note that the support material is just a little bit below 1. If we reorient the part, we may be able to reduce the time that it takes to print, but we may find that by doing so, we increase the amount of support material required to print the part. So right now we're in that standing up position, the one that GrabCAD Print recommends. Here I've laid the part flat, and you can see that although the time has been reduced by a fair amount, the amount of support material has gone up. What's significant about this is the support material is the most expensive material in the printer. So reducing the amount of support material can save money, but at the same time it may take longer to print the part in that configuration. So there's a trade-off to be made between time and support material.